Hi students, in this video I'm going to talk about introduction to electronics. So first I would like to ask this question. Why do we study electronics? The answer is because of most of electronics are available everywhere. For example, mobiles, computers, digital cameras and so on are applications to electronics. Now we want to know the voltage and current sources. Voltage can be defined as electric volt potential that derives electric charge from one position to another one. There are two sources, voltage source and current source. The first one can provide a constant voltage with different values of current, whereas the current source can provide a constant current with different values of output voltage. These sources can be modeled by these figures. Here this is the voltage source, and another one is the current source. We can see in both figures there is an internal resistance labeled by R sub I. So the output voltage here VL can be calculated using this equation. Here this V sub L is equal to V sub S times RL over RL plus R sub I. We can see from this equation VL should be less than V sub S unless that RI is equal to 0. When R sub I is equal to 0, we can say there this is voltage source is ideal voltage source. Actually there is no ideal voltage source because there is an internal resistance. Likewise here I sub L can be calculated from this equation. We can see here I sub L is equal to I sub S times this ratio R sub I divided by R sub L plus R sub I. And because R sub I is found here, some current can pass through this resistance, and the output current should be less than the input current. The students are requested to derive this equation and this equation depending on these figures. Periodic signal. Periodic signal can be defined as the signal that repeats itself within a time frame. There are two types of signals, analog signals and digital signals. In analog signals, the instant value of voltage or current can be varied with the time. One familiar example of analog signal is called sinusoidal signal, which is shown in this figure. In this figure we can see here there is a positive half cycle and negative half cycle, and this signal can repeat itself with positive, negative, and so on. And the amplitude A can be either voltage or current, and the value of the A can be different at this point from this point from this point depending on the time. However, this signal can be mathematically expressed using this equation. S of t is equal to A cosine 2 by ft plus phi. Phi is the phase difference and the f is the frequency of the signal. The frequency can be calculated from this figure. We can see here from this point to this point is a complete period and labeled by capital T. Capital T is equal 1 over f. Also here 2 by f can be expressed by omega. Omega is the angular frequency. This equation can be reduced to S sub t. S of t is equal to A cosine omega t plus phi. When the phase difference is equal to minus pi over 2, this equation can be converted to sine instead of cosine. And finally, you can use this equation cosine omega t plus phi or sine omega t plus phi to express this equation, this signal. We see in this figure the maximum value of this signal is referred to by peak amplitude of the signal A sub B, and we have already said that A may be voltage or current. If we use volt, so A sub B will become V sub B, and if we use current, A sub B will become I sub B. And from this point to this point is called peak to peak amplitude, A sub B to B, or V sub B to B, or I sub B to B. For example, if the voltage here is 5 volt, then peak to peak is equal to 10 volt. The root mean square amplitude is A sub RMS, which is equal to the A peak divided by square root 2. If we use voltage, that means V sub RMS is equal V sub B divided by square root 2. This value is measured by the voltmeter or the ohm meter. In this exercise, we see here, this is the signal, this is sinusoidal signal, and you are requested to prove that the sinusoidal signal have a frequency less than 1. It is very simple. You can use this equation and just open this. You can get this value, because sine 2 by n, and this term is equal 0. Evidently that from this figure, the ARMS should be less than the peak voltage. That means the voltage measured by the voltmeter should be less than the real voltage. Also, from this figure, we can measure the or we can calculate the power dissipated and resistance R from this equation. P is equal A sub R ms squared divided by R, and A should be equal to V, not I. Also, if we have two signals with two amplitudes, A1 and A2, and we need to compare between them, we can use this equation and this equation to compare between their power. Now we study digital signal. Digital signal is different from analog signal because it has discrete values rather than continuous values that we have already seen in the analog signal. This is an example of a digital signal, which is rectangular signal. In this signal, there's just two values. In the positive half cycle, the signal has A plus, and in the negative half cycle, the signal has amplitude of A minus, and this repeats itself: A plus, A minus, A plus and minus, and so on. Because here this is T1, here this is T1, and this is T2. Because this is T1 is not equal to T2, this is called rectangular signal. If these times are equal, like this signal, then we can say this is square signal. The ratio that determines this signal is square or other shape is called a duty cycle. Duty cycle can be calculated from this equation. D is equal W over T times 100%. In this figure, we see here this is W and here one complete period. If D is equal 50, then the wave will be square. Other value, the wave will be rectangular. Also here, the frequency is equal 1 over T is called repetition rate. This is the unit for the time. 1 second is 10 to minus 3 second, and micro, nano, pico, femto, and so on. And the digital signal can be calculated or can be represented by binary data 0, 1. We see here 1, this is equal to A plus, and here 0, 1, 0, 1, 0, and so on. Here another example for 1, 1, 0, 0, 1, 0, 1, 0. Here 1, 1. Here this is 1, 1. Then 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, and here 0. Here in this exercise, here find the digital number of the. We see here this 1, 0, 0, 0, 1, 1, 0, 1, 0, and so on for the other examples. Here duty cycle, just this W over T times 100%. If here L 10 millisecond, here this is 10 millisecond, and here high 5 millisecond. That means the W is 5 millisecond and L is 10 millisecond. Just substitute these values in the duty cycle law and you can get the value of D. In this problem, we need to know the equation of the sinusoidal graph here. First, you need to calculate the peak. The peak here from 3 to minus 7, this is equal 10, divided by 2 is equal to 5 volts. The second thing, you need to calculate C. C is equal vertical shift divided by 2. Vertical shift can be calculated from this 3 volt minus 7 volt, this minus 4. Minus 4 divided by 2 minus 2. So C minus 2. Now you use this equation, V equal A cosine omega t plus phi plus C. C minus 2. And omega is equal to 2 pi over t. 2 pi over t. T is the period from this point to this point. For example, 4 pi minus 2 pi is equal to. Or you can use from 3 pi to pi as here in this equation. In this, yes, is equal 1. Now, when omega t is equal by, you have to choose one point. This point, omega t is equal by, so V sub by is equal minus 7. Here this is equal minus 7. You can substitute these values in the equation and you will get phi is equal either 0 or 2 pi, and here this is the final equation.